The extreme value theorem states, if f is a continuous function over a closed bounded interval ab, then there is a point in ab at which f has an absolute maximum over ab, and there is a point in ab at which f has an absolute minimum over ab. We will consider the function f of x equals the square root of the quantity 4 minus x squared over the closed interval from -2 to 2. Let's ask ourselves a couple of questions. First, does the extreme value theorem guarantee the existence of an absolute maximum and a minimum for f over the interval? And if it does, where are the absolute maximum and minimum values? Let's consider the function f of x equals the square root of the quantity 4 minus x squared over the bounded interval from -2 to 2. Regarding absolute extrema, we must have a continuous function over a closed interval when using the extreme value theorem. The problem statement defines the function over a closed interval from -2 to 2, and, looking at the graph, the function appears to be continuous. So, the extreme value theorem applies. A function can have both an absolute maximum and minimum, just an absolute maximum or minimum, or neither. We will begin with considering the absolute maximum. As we trace the curve from -2 to 2, we start on the negative x-axis, rise passing through a high point at 0, 2, and fall to the positive x-axis. Let's substitute 0 into the given function. Substituting 0 into the equation for x results in the square root of 4 minus 0 squared. We know that 0 squared is 0, so you're left with the square root of 4, which is 2. So there is an absolute maximum of 2 when x equals 0. Now we will consider the absolute minimum. When tracing the graph, we start and end on the x-axis. It looks like the graph starts at x equals -2, so substitute -2 into the function and see what happens. By substituting -2 into the equation, we have the square root of 4 minus -2 squared. -2 squared is equal to 4, and 4 minus 4 is 0. The square root of 0 is 0, so there is a minimum of 0 when x equals -2. Finally, it looks like the graph ends at x equals 2, so let's substitute 2 into the function and simplify. Since -2 squared is the same as 2 squared, we have another absolute minimum of 0 when x equals 2. We have determined that the function f of x equals the square root of the quantity 4 minus x squared has a maximum of 2 when x equals 0, and two minimums of 0, one when x equals -2, and a second when x equals 2, over the bounded interval from -2 to 2.